All right, so you've handed us a whole stack of info on becoming an electromechanical engineer. Seems like you're serious about building the future.
Building the future. Yeah, that's a great way to put it. Not just circuits on a board, but like the whole electromechanical package.
Yeah, it's about robots, smart devices, and all that really cool stuff, right? So it sounds like it's a good time to be an electromechanical engineer.
Absolutely. Integrating those electrical and mechanical systems more and more important now than ever. This field is absolutely exploding because of it. So the job outlook is fantastic.
That's what we like to hear.
In fact, this guide mentions faster than average job growth,
Yeah.
which is always a good sign for anybody, considering a career path.
Right.
Uh,
But they also mention hazardous environments.
Right.
Should we be worried about that?
it's not as intimidating as it sounds.
Okay.
Think of it this way. Where are things built and designed?
Okay.
Manufacturing plants are one setting, of course,
Sure.
but you also have engineering firms, those cutting-edge R&D labs. Even government agencies need these skills for all sorts of projects.
Right.
It's a much more diverse field in terms of environments than a lot of people think.
Okay, that makes sense. Speaking of diverse, this guide lists a ton of skills needed to be successful.
Yeah.
They range from the technical complex problem solving at 61%, then judgment and decision making,
Right.
to what I would call essential skills for any job, reading comprehension and good old-fashioned teamwork.
Sure.
Is this job all work and no play, or can an electromechanical engineer still let their creativity shine?
You've hit on a really crucial point. It's not just about, crunching numbers and memorizing textbooks.
Right.
The guide actually emphasizes creativity as much as technical know-how. You've got to have that passion for figuring things out.
Yeah.
Think about it. Designing something like a new electric car
Okay.
means you need to understand the mechanics and the power systems,
Yeah.
all while making it efficient and something people actually want to drive.
Right. And desirable and all that. But you're not just thrown into the deep end from day one, are you?
Right. This guide does a really great job of breaking down the different stages of a typical career path, from entry level to senior engineer.
Okay.
Starting out, you're assisting the more experienced engineers, drafting up plans, maybe doing some testing.
Right.
By the time you hit mid-level, you're probably leading projects, taking on more responsibility.
Sure.
And before you know it, you're the one providing strategic direction for the whole team. It's quite a journey.
Yeah, it sounds like a career where you're constantly learning and growing,
Absolutely.
which I imagine is exciting for the right person.
And the guide emphasizes how important that is. It specifically mentions staying updated through industry journals, attending conferences, even participating in online forums.
Oh, wow.
Electromechanical engineering is definitely a field that's evolving rapidly. I bet there are entirely new specialties popping up every day.
I bet.
Yeah.
Okay, so let's say after reading through all of this, you're totally sold on becoming an electromechanical engineer.
Okay.
This guide has a really comprehensive section on how to ace the interview. Let's walk through it together, shall we? Question 1 is a real doozy. Tell us about your experience with electromechanical systems,
Okay.
not just components
Right.
systems.
Yeah.
Yikes. Where do you even begin to answer that one?
You're right. That's a broad question, but it's a fantastic opportunity to showcase your passion. This is where specific examples are going to be key.
Okay.
Think back to your past experiences and any projects you might have worked on.
Okay.
Did you build anything cool in school? Maybe tinkered with robotics kits in your garage? It doesn't have to be professional experience at this stage. Employers want to see that innate interest and drive to tinker.
So they're not just looking for someone who can regurgitate textbook definitions.
Exactly. They want to see problem solving in action.
Right.
The guide also mentions that you'll be asked about troubleshooting teamwork, optimizing for efficiency. It all boils down to showing, not just telling.
So how do you prepare for that?
Think back to your projects and ask yourself some questions. Where did you encounter a challenge? How did you work through it, maybe even with others? Did you have to get creative? Maybe you had to compromise. Those stories are going to make you memorable and show the interviewer that you can think on your feet.
It sounds like they're really looking for that spark, that genuine passion for figuring things out and building cool stuff.
Absolutely.
Which makes sense.
Yeah.
Being passionate about what you do makes the long hours and hazardous environments worth it, right?
Absolutely. And speaking of things that make the challenges worth it, the guide also mentions that the career path often comes with a very nice salary and plenty of opportunities for advancement. Not bad. Not bad at all.
Not bad at all. But it's not just about the paycheck, is it?
Right.
There's something pretty amazing about knowing that you're part of building the future, right?
100%. What I find fascinating is how this one role, electromechanical engineering, touches on so many aspects of modern life.
Totally.
From the phone in your pocket to the future of transportation and beyond.
Yeah.
These are the engineers who are shaping the world around us.
That's an awesome point. It's bigger than just one person or one project. It's about contributing to something much larger than yourself.
Exactly. And speaking of contributing to something larger than yourself,
Yeah.
let's talk about some of these amazing specializations within the field of electromechanical engineering.
Okay.
Did you know that you could be a smart home engineer?
A smart home engineer? What does that even entail? It sounds so futuristic.
It does, but it makes perfect sense given how integrated technology is in our homes now.
Right.
This guide positions this specialization as a blend of electrical engineering, mechanical engineering, and computer science.
Yeah.
Almost like being a digital architect of a living space.
Oh, wow. That is so cool.
That's
And with the rise of the Internet of Things, that specialization is only going to become more important.
Oh, for sure.
But if you are someone who likes things a little more high voltage,
Right?
there's always the electric power generation engineer.
Oh, yeah.
Now that sounds pretty powerful.
Talk about a powerful career. Instead of working on a small scale, you're talking about designing and maintaining the systems that power entire cities. It's a huge responsibility.
Yeah.
But can you imagine the feeling of knowing you're helping to keep the lights on?
That's amazing.
Yeah.
Okay, one last specialization before we move on. The electromagnetic engineer.
Okay.
What do they do? Work with antennas and radar systems.
That's part of it.
Mm-hmm.
But they also work with everything from medical imaging devices to even things like maglev trains.
Wow.
It's like they're harnessing invisible forces to create some truly incredible technology.
It's mind-blowing when you think about it. From powering entire cities to developing new medical technology to designing the next generation of smart homes,
Right.
electromechanical engineering is behind so much of what makes the modern world tick.
It truly is. And speaking of making the modern world tick, this guide does a deep dive into some of the essential skills needed to break into this field.
All right, so let's take a look. So we've talked about a few really exciting and diverse specializations within electromechanical engineering. But before we get too carried away dreaming about designing smart homes and high-speed maglev trains, let's take a look at some of the essential skills you'll need to break into this field.
That sounds like a great plan. It's important to have a realistic understanding of what it takes to be successful as an electromechanical engineer. It's not always robots and high-tech gadgets.
So it's not all fun and games. What kind of skills are we talking about here?
Well, this guy does a great job of breaking it down into these specific areas, even assigning percentages to certain skills based on their importance in the field.
Percentages. That's pretty cool, actually. Let's hear it.
Okay, so at the very top of the list, we have complex problem solving at a whopping 61%. That makes sense, though, right?
Yeah.
When you think about the very nature of engineering, it's all about identifying problems and designing solutions.
That's true. You can't be afraid of a challenge if you want to be an engineer. So what comes after problem solving?
Next up is judgment and decision-making at 55%. Now, this one might seem a bit more vague, but it speaks to the level of responsibility that comes with being an electromechanical engineer.
Yeah.
You're not just designing something in a vacuum. You have to consider things like safety, efficiency, cost, and even environmental impact. You're constantly weighing different factors and making decisions that could have real-world consequences.
Right. It's not just about what works on paper. It has to work in the real world, and it has to work safely and effectively.
Precisely. And speaking of things that have to work safely and effectively, the guide also mentions systems analysis at 47% and systems evaluation at 42%.
So being able to analyze and evaluate how different systems work together is just as important as being able to design them in the first place.
That's a great way to put it. You have to be able to look at the big picture.
Right.
How do all of these different components and systems interact with each other? Where are the potential points of failure? How can we optimize for efficiency and safety?
You really have to have that systems thinking mindset, right?
Absolutely. And you know what? This actually ties back to what we were talking about earlier with those exciting specializations. Think about the smart home engineer. They need to have an incredibly strong grasp of systems thinking because they're not just designing a lighting system or a security system. They're designing how all those systems work together seamlessly.
It's like they're conducting an orchestra of interconnected devices.
I love that analogy. And this guide emphasizes that it's not enough to just have a deep understanding of these technical concepts. You also need to be able to communicate your ideas effectively to others, both verbally and in writing.
Because at the end of the day, engineering is a collaborative field.
Exactly. The guide specifically lists reading comprehension and active listening as essential skills. You're going to be reading a lot of technical documents, research papers, and design specs, and you're going to be working closely with other engineers, technicians, and even clients.
So being able to effectively communicate complex ideas in a way that is clear, concise, and easy to understand is crucial. No one wants to work with someone who can't explain what they're doing or why they're doing it.
Exactly. And it's not just about explaining your work to others. The guide also lists critical thinking as an essential skill, which means being able to evaluate information, objectively identify biases, and form your own conclusions based on the available evidence.
Right. That's important for any field, really, but especially engineering, where you are dealing with complex systems and making decisions that could have a big impact.
Absolutely. Now, shifting gears a little bit, let's talk about the actual work environment for an electromechanical engineer. Remember earlier when we mentioned hazardous environments?
I do. You had said that it's not as intimidating as it sounds, but there are still some things you need to be aware of, right?
Right. The guide touches on this too. You might be working in a manufacturing plant with heavy machinery, or maybe you're out in the field working on a large-scale infrastructure project.
So you might need to be comfortable wearing a hard hat and steel-toed boots from time to time.
Exactly. And you might need to be comfortable working in tight spaces or at heights, depending on the specific project. But it's not all about physical risk.
Oh, what else is there?
Well, this guide also highlights the mental demands of the job.
What do you mean?
Well, think about it. You're often working under tight deadlines, solving complex problems, and dealing with a lot of responsibility. That can be pretty stressful, and you need to be able to manage that stress effectively.
It sounds like you need to be the kind of person who thrives under pressure. Someone who is deadline-driven, detail-oriented, and not afraid to put in the extra hours when needed.
Exactly. And on that note, let's talk a little bit about work-life balance. The guide doesn't shy away from the fact that electromechanical engineers often work long and irregular hours.
Especially when project deadlines are looming.
You got it. It's not uncommon for engineers to be pulling all-nighters or working weekends to get the job done, especially in those fast-paced, high-pressure work environments.
So it's not always a 9-to-5 job.
Definitely not. But here's the thing. While the long hours and demanding deadlines can be challenging, they can also be incredibly rewarding. There's a real sense of accomplishment that comes with seeing a project through from start to finish.
It's that feeling of, I built that.
Exactly. And speaking of building things, let's dive back into some of those specific tasks that you might be doing on a day-to-day basis as an electromechanical engineer. This guide goes into great detail, even mentioning some very specific technical tasks.
No. Like what?
Well, for example, you might be tasked with analyzing test data. That means collecting data from experiments and simulations, then using that data to evaluate the performance of a design or to identify potential areas for improvement.
That sounds like it requires some pretty strong analytical skills.
Absolutely. And then there's monitoring manufacturing quality standards.
That sounds important.
Right.
What does that involve? So making sure those manufacturing quality standards are being met, that's going to be crucial, especially when we're talking about, things like safety and reliability.
Absolutely. You're responsible for ensuring that that final product meets all the necessary specifications and regulations. We're talking about, potentially life-saving devices or systems that need to function flawlessly under pressure.
Yeah, you definitely don't want to cut corners when it comes to quality control. But it's not all about analysis and monitoring, is it? You also get to do some hands-on designing and building too, right?
100%. This guide highlights how electromechanical engineers might find themselves developing and testing prototypes using computer-aided design, CAD software, to create detailed models, and even working with their hands to assemble and troubleshoot those physical components. It's a dynamic blend of analytical thinking and practical skills.
It's like the best of both worlds. You get to think big picture, A&D, get your hands sturdy. Speaking of big picture thinking, we were talking earlier about the different career paths you can take with an electromechanical engineering background. This guide does a really great job of laying out some really cool options.
It really does. We already touched on the smart home engineer and the electric power generation engineer, but there are so many other exciting possibilities within this field.
Like what? Give us some more examples. What else could you be?
Well, for starters, there's the mechatronics engineer.
Okay, mechatronics, that sounds pretty high tech. What exactly is mechatronics?
It's a fascinating and rapidly growing field that combines mechanical engineering, electronics, computer engineering, and even a bit of software development.
So it's like the ultimate interdisciplinary field.
Exactly. Mechatronics engineers are involved in designing, developing all sorts of innovative products and systems. Everything from advanced robotics and automated manufacturing systems to medical devices and consumer electronics.
So if you have a knack for both the mechanical and the electrical, and you love that idea of integrating software and control systems, mechatronics could be the perfect path for you.
Absolutely. And speaking of integrating software and control systems, another exciting career path highlighted in this guide is control systems engineer.
So that's like designing the brains behind all these complex systems, right?
Exactly. They work on everything from industrial automation to aerospace and robotics. Basically, anywhere you have a system that needs to be controlled and monitored.
So if you decide to become a controls engineer, you might find yourself designing the control systems for a self-driving car, or maybe even a Mars rover. That's so cool.
It really is. And speaking of cool technology, the guide also mentions a path that might appeal to those with an interest in the really, really small, becoming a microsystems engineer.
Oh, yes. We touched on this one earlier. It's all about those tiny, intricate devices that are becoming more and more important in today's world.
Exactly. They're the masterminds behind things like microchips, sensors, and actuators. Those tiny components that are revolutionizing everything from smartphones and wearable tech to medical devices and renewable energy systems.
It's incredible to think about how much innovation is happening at such a small scale.
It really is mind-boggling. And the guide emphasizes that a career as a microsystems engineer often involves working at that cutting edge of technology, collaborating with experts from various disciplines, and really pushing the boundaries of what's possible.
So it's a career path with a lot of potential for growth and discovery.
Absolutely.
Now, before we wrap things up, let's talk about the elephant in the room, or maybe I should say the robot in the room.
Right.
With all the talk of automation and AI, is it possible that electromechanical engineers might end up designing themselves out of a job?
That's a question that comes up a lot these days, but honestly, this guide argues that the opposite is true. While it's true that automation and AI will continue to change the job market, you'll also create new opportunities for skilled engineers.
So instead of replacing engineers, these advancements will actually increase the demand for their skills.
Exactly. Think about it. Someone still needs to design, build, program, and maintain all those robots and AI systems. That's where electromechanical engineers come in.
It's not about being replaced by technology. It's about learning to work with technology.
You got it. And in fact, this guide stresses the importance of continuous learning and upskilling for anyone entering this field.
So being adaptable and staying up to date on the latest technologies is absolutely crucial.
Absolutely. Electromechanical engineering is a dynamic and ever-evolving field, so a willingness to learn, grow, and embrace new challenges is essential.
It sounds like if you're someone who loves to learn, loves to solve problems, and is excited about the future of technology, then a career in electromechanical engineering could be the perfect fit.
I couldn't agree more. And on that note, we've reached the end of our deep dive.
And hopefully you've surfaced with a newfound appreciation for this amazing world of electromechanical engineering. It's a challenging field, no doubt, but it's also one that's incredibly rewarding and full of exciting possibilities. So if this deep dive has sparked your curiosity, why not take that next step and explore some of the resources we've discussed today? You never know, you might just discover your future calling. Thanks for joining us.